So slope fields, let's get going, calculators. And we will, slope fields are a process for solving differential equations. A differential equation is an equation that has a derivative already in it. dy dx equals some function, or f prime of x, or even h double prime. These are all differential equations. And to solve a differential equation, we want to figure out what the plane y is, or the plane f of x. Or in this case, what could we solve for? The h prime of t, yeah, h prime of t. And then we could actually do another one and solve for h of t. We can actually solve these differential equations twice. But a slope field, typically, if I ever have to use a slope field, it's with the differential equation that I cannot solve in other methods. But we're going to practice finding slope fields. A slope field is just a field of little teeny tiny sloped lines. In fact, when I took calculus, I don't even remember them. So I don't know if we did them when I was in school or not. But no, they are part of our curriculum and they're part of the AP exam. So if we are given a differential equation, what we can do is we can take all of the points that are given in this little bitty grid. Give me all the points that you see. 0, 0, 1, 0, 2, 0, 2, 1, 1, 1, 0, 1, negative 1, 1. All of these little points, we will create a little bitty sloped line. And what shows up is a general view of what the actual solution is.
Oh, it is.
So, and the beauty is, if we only have one value, the x value, it does not matter what the y value is, right? So if I choose x equals 0, all of these points have an x value of what?
0.
And what is 0 squared?
0.
0. So we're going to draw all of these little bitty 0 sloped lines on the y-axis. All of those. And even the halves could have 0. I mean, you could draw an infinite number of little sloped lines with 0 slopes. All right. All of the x values on these points. 1. What's 1 squared? How do I draw a slope of 1? 45 degrees, right? So we're going to go 45 degrees. I'm actually just mentally rise 1, run 1. This one doesn't look great. That's the one thing that I always said on the AP exam. How are they going to grade these? How strict are they going to be? Well, a protractor. They're not going to do a protractor. I believe if it is a slope that's supposed to be less than 1, they want it less than 45 degrees. If it's greater than 1, they want it to be sloped higher. I'm pretty sure. And if it's positive, it's got to go up to the right. What about all the 2 values?
4.
2 squared is 4. Now, some teachers teach actually filling in a big table. Well, on these, I really think mental is not bad. 1, 2, 3, 4. So I'm going rise 4. 1, 2, 3, 4, run 1. So I'm mentally connecting this point with that point. It's pretty steep, isn't it? This is, again, one of those not exact sciences, and you know me, I like the exact values if at all possible.
The less accurate it needs to be, the better it is for the...
What is Negative 1 squared, all of these. 1. So we've got another 45-degree little sloped lines, right? What about negative 2 squared? 4 again, right? 1, 2, 3, 4 over 1. I gotta be honest, y'all, slope fields give me a headache. If I have to do too many of them, and if they're X's and Y's mixed, it takes a while.
Yeah, that means you should just give us like a really small slope.
So, we have just now drawn a slope field. When drawing a piece of a tangent line, draw the line long enough to see, but not so long that it interferes with other points. What's your question?
I was wondering, could you, I'll ask you after class. Sorry, it's a particular.
Okay. So, that's a slope field. The next item is if we're given an initial value, okay? So I'm going to say, after we draw a slope field, the purpose of it is to be able to actually solve the differential equation. So if I say y of 1 is negative 1, then we can draw a solution to it, okay? So I'm going to draw that in red. If y of 1 is negative 1, that will be on my curve, right? And then if we follow the slopes on the right side, what do you think this curve is going to be doing?
Going up,
Heading up to the right. And as we keep going this way, what do you think is going to happen?
Going down.
It's going to end up going down to the left. So, I can't stop here because slope fields to solve this differential equation are not the best. You know me, I want precise, right? If dy dx is x squared, that's what f prime of x is, right? How do I go to f of x? An integral. Guys, this is called a separable differential equation, and I literally can take an antiderivative of x squared by itself. What is it?
X cubed.
Plus a c value. So literally, if I'm given that y of 1 is negative 1, I literally can get an exact solution. Put a negative 1 in for y, a positive 1 in for x, subtract 1/3, what do we get? Negative 4/3. And guys, does this look like a cubic function that has been moved down 1 and 1/3? I mean, it's pretty close. I had a little funkiness going on with the line. It probably should have gotten a little bit higher. Mine looks more like negative 3/2 instead of negative 4/3.
This is so close. It's nice to see like differentiation and integration. It's like different operations. This is weird. Almost.
And by the way, if that initial value or boundary value is not the same, we actually can draw several more like possible solutions to this. Agreed?
Whoa.
All of the, oops, I should have made that flat, shouldn't I? At the 0, it's got to be flat. That's, So these are all possible solutions as long as this is not given. If this is not given, we have an infinite number of possible solutions. And we know we do because of the C value. Does that make
But
sense?
If it says y of 1 is -1, or it's not -1 anymore, or
Yeah, so these blue ones are not solutions to this. Only the red one is the solution to that one, right?
but when you don't have that, it could be any number of infinite solutions.
And if you don't have a boundary condition or an initial value condition, you don't know what the answer is exactly.
Infinity raised to infinite power infinitely.
All right, so this one, here's where, now, thankfully, we only have an x value again. So this one, while it has a bazillion dots, and we're counting each of those as one unit, right? At least, we really only have 1, 2, 3, 4, 5, 6, 7 slopes to find, right? All of the x values of 0, what's the slope? 1, 45 degrees.
I really don't like these at all.
Yeah, you do.
No, I don't.
Not having to draw them. I've seen more on the AP exam where you're matching things,
Oh, that's.
so it's easier. Yeah. What about if x equals 1? 2 times 1, 3. So 1, 2, 3 over 1. Does that look good enough? And then just do. I'm so bad at
That
this.
part's kind of hard.
I'm doing
I know.
nation.
Make sure they're not. Mine just
What about if x equals 2?
5.
2 times 2 is 4 plus 1 is 5. It's going to be steeper, 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 steeper. And this one is going to be super steep, right? Super steep. Just go almost vertical. How about -1?
Negative 1.
No, 2 times -1. Oh, is -1 plus 1. You're right. -1. I was thinking a half for some reason. You know.
It's okay. Miles should be easy.
Negative. So guys, what's going to happen at x equals -1/2? -1/2 times 2. So essentially, right in the middle, we have a bunch of zeros, right? So if we're following our sloped lines, it's going to,
So would it be legal to, since they're not labeled, to make the units negative and positive 1/2?
It would be if you really wanted to. Yeah.
That'd be stupid.
You could have called it 1/2, 1, 3/2. Might have been less steep lines. Plug in a 2, -2, -4 plus 1 is -3, 1, 2, 3. And -6, -5. So steeper still. All right. And again,
It's a pretty cool art piece.
That's what I'm saying.
if we drew in a few solutions, would you agree with these solutions?
Yeah.
You've never seen the art museum of slow fields? That's what they're.
And by the way, what is the antiderivative of a linear function?
Just quadratic.
A quadratic, which is a parabola.
Oh my goodness.
All right. Now, finally, we have one where the x's and y's are mixed up, are
Wait,
together.
can I guess what you do. You just go to each point and like for 0, 1, you put the 0 in and the 1 in. Oh.
Each point.
That's the first thing I
Now,
actually knew this
the
year.
beauty is finding some things that happen. Like, what will make this undefined for y? 0 for y, but not for x. So 0 for y's, I'm going to go and do, except for that one is going to be a weird one, right? And now, how about 0 for x, though, except for this point?
It's gonna be
0. So all of these would be 0. Agreed? So that's what I look for. I look for little patterns that help me make this less headache inducing. What about 1/1? -1/1. -1. Negative 2 over 2, also negative 1. See, these are the ones that I look for little patterns. Negative 1 over negative 1 would still be a negative slope, right?
Yep.
3 negatives. What about 1 and negative 1? Positive 1? Are these all positives? Negative 1, positive 1, still have 2 negatives, which would make a positive. Shoo! So I filled in a bunch of them just using patterns. Does that make sense?
It's just the scope.
And then 1, 2.
This better keep going.
1 over 2. Negative 1/2 down 1 over 2 would be flatter than the negative 1. Not quite flat enough, maybe. I don't know. This one would be 1/3, so even flatter. Would these be the positives? Negative 1, 2, negative 1 over negative 1 would be positive 1 over 2. Positive 1 over 3, flatter. Are you seeing some symmetry?
Form swirls.
Yeah, looking like swirls.
Why do you
2,
hate those
1.
dots? It's so perfect. My eyes are bad. Your eyes are bad.
Negative 2, down 2, over 1.
Worse than yours.
Say it out loud.
I don't remember the number.
Okay, well then.
Negative 2, 1.
Set up perfect.
Negative would be positive.
We're talking about people
I
perspective,
think
not
that's
human
scientific.
perspective.
Are you getting the feeling why I say this induces headaches?
No, I like it actually.
Probably because of us.
2,
Art kid, probably.
2, negative 1 would make it positive 2, right?
But this is fun because we're making
1, negative 2,
math for
positive 1/2. Negative 1/2 here. 1, 2, negative 2. Oh, goodness. I will say I've never seen more than 12 dots on an AP problem. So this is like at least more than twice more.
But it's kind of swirly.
3.
Worth it.
Negative 3, positive 1 would make it positive 3. Negative 3, 2 would be slight, it would be between these two, right? Negative 2, 3, still positive. All right. Can y'all finish these?
Yeah.
Just estimate. Steeper.
Oh, he's gone.
We were standing in the culinary line and I was watching an Instagram live where they were just putting a hat on a frog. It's amazing.
Why do you waste your time?
Wasted
All right.
what?
I just trying to use a little bit of symmetry. All right. And guys, it does look like it's a perfect circle. I will tell you though, for whatever reason on the AP exam, they want first of all, the answers to be functions. So they're not going to cross above and below a vertical asymptote thing, right? So you're either going to have some top halves of circles here, right? Or you're going to have
Some bottom half.
some bottom halves, right?
That's what I'm
That's so goofy.
I think it looks like a perfect circle. I really don't think it's a parabola.
It's not.
Well, a circle. is two
Guys,
sides.
this one turns out to still be separable if I multiply by a dx and multiply by a y on both sides. Somebody tell me what that actually looks like.
Y dy equal to d.
Negative x dx. And guys, we've never looked at a problem like this, but we actually can solve this. Somebody give me that antiderivative.
Y equals
Negative x squared.
Plus a c, right?
Multiply by 2.
And so, yeah,
Y equals x.
if we take it over, y squared plus x squared equals 2 times c, right? Which is some other c. This is the equation of a circle, but again, depending on if they said that y of 2 equals 2, then you can solve for c, and I'm going to find a different, I'll just draw it in black. If I drew this solution, 1, 2, 2, then what I'm going to do, follow the sloped lines, and I'm going to end at the vertical. It's going to be a positive answer, is what it's going to be. And the reason now I've seen our book, I've seen some other worksheets and AP review stuff. See, if I solve for y, c minus x squared, isn't it plus or minus the square root of c minus x squared?
Yeah.
And so if that y of 2 is a positive 2, which version of this would we use? The positive square root of c. Well, that 2 for the y and 2 squared here. If I square both sides, what do I get? So c would equal 8. So the actual solution would be the square root of 8 minus x squared. What's the square root of 8? 2 root 2, which is 3 point something. So my solution curve looks at least somewhat close.
Can't you just follow through?
This whole stack of stuff we did is not coming until the 6-3 section, which I'm doing next. So we're going to get into, this is preview, yes.
I hate previews.
I'm sorry. Now, I got to be honest, this is a perfect one. Could we possibly split that up and get, if we call this dy dx, is there any way we can get only the x's on the right side and get the y to the left?
I don't think so.
No, because we have this division here. So this is called a non-separable differential equation. One of our only recourses is to solve it with a slope field. So let's plug in some points. 0 plus 0. 0 plus 1. 0 plus 2. 0 plus negative 1. 0 plus negative 2. It's not horrible. 1 plus 1. What? 2. 1 plus 1 is 2. Oh, I'm sorry. 1 plus 0 was 1, people. I was pointing at the 0 point, so 1 plus 1. 2. 1 plus 2, 3. What about 1 minus 1? Oh. What about 2 minus 2? What about negative 1 plus 1? So I try to find those easy points. Ooh, do we have, the negative 1 plus negative 1 is negative 2, right? All right, so negative 1 plus 0, negative 1 minus 1, negative 2, negative 3 here. What about negative 1 plus 2? 1. 2 plus 0, rise 2, run 1, 2 plus 1, 3, 4.
We discussed it.
2 minus 1 is positive 1, right? 1, 2, 3 plus 0, 3, 4. Very steep. 3 minus 1, 2. 3 minus 2, 1, 45 degrees. 1 minus 2. Guys, this is another point, like negative 2 plus 1. This is like a slant asymptote for our graph. If you notice, there's a row of linear, same sloped. Negative 2 plus 0.
And there's also a row of zeros, which look kind of goofy.
Negative 2, 3, negative 3, negative 4.
It looks.
Actually, I like this one.
Negative 3 plus 1 is negative 2.
Yeah, fishy swimming.
Negative 3. Steeper, steeper.
It's
That
like,
look
it's
good?
like air getting blown out by a hair dryer.
Did you bury the whole thing? You ever threw back in?
So, there's our slope field. Y of 0 equals 1. Bring your colored pencil or your pen or whatever, put in the dot. Then we're going to follow the sloped lines, right? Up to the right. We see a slant asymptote. What do slant asymptotes like show us?
Where are they?
That's not.
End behavior. End behavior.
What was the thing?
It goes up and then goes down. Avoiding positivity versus negative.
But let's say our y of 0 was negative 2. See, then we're on the bottom half,
It would have to be the other way.
and it would be the, like not the parabola-ish thing, just the little swoop down. Does that make sense? Do y'all remember
Yes.
doing that in pre-calc?
Very, very
We
low.
also did it on test this year.
This problem right here reminds me of something you could see on the AP. 1, 2, 3, 4, 5, 6, 9 points. This is what I've seen, on the AP. So, point by point, what's 0 plus 0? Minus 1 is 0, 1. 0 plus 1 minus 1 would be about 0, negative 1. Still 0. 1, 0. 1, 0 again? 1
Yeah.
plus 0 minus 1. Is the same thing going to happen over here?
Yes.
Yeah.
How about the point 1, 1?
Let's go.
1 squared plus 1 is 2 minus 1 is 1. Is this also positive 1?
Yes.
Because they're square.
Yeah, because they're squared. Is this also positive 1? This is not as cool. It's kind of weird looking.
Doesn't even have a good pattern. It's just stupid.
So 0, 0. All right, this is my guess because I see them curving up, but aren't all of the zeros 0?
Wouldn't it be like a?
No, it's not. What would it be over here at 2, 0? It would be 3. So are we going to hit this thing and then just go up that way? And then we're going to hit over here and go down that way?
Oh, so it's just a nice wacky.
I mean, that's my guess. That's a very difficult one because we did so few points. I don't really know what the ends look like.
That's probably about right.
Couldn't you do an end behavior for it though?
I guess. Yeah, the
Do a little
Well, we're only looking at slopes, though. We can say the slopes will always approach. So we know we're gonna be coming from this direction and going in that direction. So, then the next idea is to be able to read carefully. Sometimes you're gonna match the differential, the slope field to the differential equation, like down here. But sometimes you're gonna match it with its solution. So the solution is like, somebody give me a general shape of what this looks like, the solution.
It looks like a fish swimming down.
Yeah.
What does that look like?
It looks like,
E's are this.
yeah, but
No,
can't,
that's
no, I know, but can't natural
Natural
log not
log.
be past zero?
Well, if you look, my solution curve was not good. I should have made it go straight down
Yeah,
like
the
that.
thing is for that one over there, is having a slope past zero.
It does go
On-
with slope though.
On the left side, but this is a log curve.
No, I agree, but that's, I'm confused because if it's
Um,
terminated zero and you
It, all right,
vertical,
if we went to the other side and we saw these, then that solution would have been y equals ln of negative x. Over here, if the solution point had been over here, then it would just be a negative right there. Remember, the whatever this is, when we have an antiderivative, or
absolute value.
we have absolute value. So it can either be on the right side or on the left side for ln's if they are solutions. I mean, if it was 1 over x, right? This is ln absolute value of x. All right. So we are matching the slope field. Guys, what is the antiderivative of an e to the x function?
E to the x.
E to the x plus c. So the only one that could possibly be the solution to that one is what?
The one that looks like an immediate X graph?
Which one is?
B.
What?
No,
You're not, oh wait, no. It's
B looks like a parabola.
Oh, yeah, sure, it's gonna be a-
F is the one that looks like, right?
Yeah.
Oh, this is like exponential.
At that point, at this point, everybody with me?
Yeah.
Wait, come on number 3, what did you say it was again?
Miles, pay attention.
For number what?
Or example 3, what did we?
Calm down,
Oh, you
bud.
said it was not one of that. Okay.
For this one, if you don't want to think of the antiderivative, and honestly, I don't want to think of the antiderivative of this one either. What you can do is look, like if I have a y value of 0, in other words, on the y-axis, I'm sorry, x-axis, if the y value is 0, what is the slope of any point?
undefined.
Undefined, which is a vertical line. Not vertical, not vertical, not really vertical, not vertical. Is this the only one that has a vertical one?
Are those vertical?
Yes.
Hey,
Yeah.
don't. What's it?
Yeah.
Yeah, I mean, they're kind of leading down. They're not drawing the vertical ones,
Yeah, they're like,
but C has got to
It
be.
also follows like the,
It's the inverse of the one that we did on.
So for number 3, or I, for I,
For number I.
it doesn't matter for the x values, only the y values matter. I'm feeling A is, because all of the x's,
yeah.
I'm feeling A is in the running, let's check it. If y is 2, 2 minus 2 is, all of them are zeros. If y is 0, 2 minus 0 is 2, is that a rise 2, run 1?
So you
Gotta be
just always
A.
wanna look for a pattern that would be easily recognized.
Yeah, and if all else fails, if you've narrowed it down to 2 or 3, then what I do is I pick a point. So for D, I'm picking the point 1, 1. What is the slope for 1, 1? 1. So 1 works for that one. 1 minus 0 works for that one. The sine of 1? No. Well, yeah, I guess it does. Because this is not, if I look at this,
FCA.
Four isn't it either B or D?
For Christian athletes.
I put B.
if x is 1, all these are 1s, x is 2, all these are 2, x is negative 1, that's gotta be a b, doesn't it?
Yeah, because the other one's weird.
I can't
I
believe
mean, I'm feeling like the solution to a sine curve, though, is it's a negative cosine, isn't it? So it would be, D has got to be VI, doesn't it? So does V work for, guys, what's 1 minus 1? 0. 2 minus 2?
0.
3 minus 3?
0.
Gotta be E.
Fellowship for Christian athlete bed.
Bed.
FCA is the.
FCA bed? Okay. All right. So, literally for homework, I have one worksheet.
Say less.